All right, guys. So, um, I don't think the YouTube app has a way to make the screen brighter, like as though it's some sort of like pseudo flashlight. So I guess I don't have a flashlight. So I'm just trying to think, how do I solve this problem? Because I came up with this problem of thinking about black holes and then realizing that we probably, more likely than not, in my opinion, um, have our observable universe inside of a black hole, which, from our perspective, this is my opinion, this is my what makes sense to me as most probable. It's a white hole from our perspective, and a white hole is basically the opposite of a black hole, and it matches what we observe around us. So when you say, "Oh, you can't approach the edge of the observable universe because you'd have to go faster than the speed of light in theory or whatever." Well, the modeling that they're doing actually matches perfectly with a with what you would see around you if you were inside of a black hole, and you could actually call that that surrounding surface of white hole the unapproachable surface, because it's basically coming at you. It's spewing space time at you faster than you could approach it, which makes sense because, I mean, a black hole would be sucking all that in. Um, it's a weird thing to think about because it's not traditional. It's in our intuition. Traditional in our intuition is just you know, basic three-dimensional objects essentially. That's about it. Um, Guys, what I'm trying to figure out right now, conceptually, this is a weird thing. I know it sounds weird, but it has to do with the second law of thermodynamics and trying to properly um, come up with basically trying to come up with an abstract concept of something similar to that idea. So, similar to the idea of thinking of our observable universe basically both being a black hole or a white hole, depending on the perspective. I'm trying to think about how we deal with the equation in the second law of thermodynamics when it comes to the heat transfer. Because apparently they have an equation, and I'm not used to using it, so that's part of the issue. But basically, when you have a hot cup of tea, you can kind of think of the energy coming away from that and then going on around to the surrounding area. Now, like I said before, right? Reversible physics means that your particles bouncing are indistinguishable whether going forwards or backwards in time. So there's obviously no such thing as like an increasing disorder when you just have the bouncing particles, right? But when you increase the volume, or when you assume that you magically remove this veil between two volumes, then suddenly you get this system where there's more possible states that you can't return to originally. Um, but that's changing the system fundamentally. You're changing the volume, you're combining two separated volumes into one combined volume. That's not reversible physics. Reversible physics is indistinguishable. It's just bouncing particles, and it's indistinguishable um, from normal from its opposite. And like I said, and maybe I don't know if I've mentioned this too much in my videos, but the first time I heard the single electron theory, I immediately thought that it was intuitive and that it was more likely to be true than not. That was my very first thought of that. Might have been all the way back in high school. I don't remember when that was, but it immediately made sense to me because you have um, annihilation and you also have particles that seem to come out of nowhere, and there's always like two of them, like an anti-particle and a regular particle, and it's like, well, it's one particle that's just bouncing, but in time it's just switching between going forwards in time and backwards in time. So what I want to understand, like, if let's think about just the particle, like forget about relativity for a second, right? um which is not something I usually would say, but like, just thinking about the because of the particle bouncing simulations, right? We know those are reversible. So okay, if that's true, fine, great. Then now let's think about the how do we simulate a hot cup of tea or whatever in a particle bouncing simulation, right? Because remember, reversible or not reversible. I mean, in reverse, straight forward or reverse, it doesn't matter, right? Reversible means either way, it's indistinguishable, which means that if we have a simulation using these particles of like a hot cup of tea, then that means that it's not going to tend to just cool down in this very bare bones simulation. It can't. Why? Because the forwards and backwards are indistinguishable. So that means that the heat balancing out would have to be just as likely as the heat kind of separating itself again. Right? So my guess is there's so my thinking on this is maybe some people attribute order to kind of this, maybe they can think of it as separation of actual spots, like volumes of hot and cold. But if it's really truly indistinguishable, I mean, that means that somewhere in the middle of a simulation, say, you could have different spots of hot and cold, and it doesn't matter if you go forwards or backwards in time, you won't tend to basically get more of those on a global scale. Yeah, everything will mix. So that's sort of one theory. So one argument someone might come up with. They might say, okay, well, fine. It doesn't matter if it's reversible. They'll just say whether you go forwards or backwards in time, all the heat will kind of mix around evenly either way. It doesn't matter. But if you want to pick something that looks cool to a human, that separates all the particles, into half of the side of the volume or something like that, it's unlikely to get to that state. But it doesn't matter whether you're going forwards and backwards in time. What you did was you picked that state to be there at that particular time. So the point is that the more interesting question is not whether the particles can be in just half of the volume, but whether you can get them to return to that more than one time after mixing together. Does that make any sense? Can you have all the particles kind of like in one half of the container, and then they go out and bounce around, and then they kind of randomly just all happen to be in the half of the container again? That would be, statistically, unlikely, given like, uniform random directions of bouncing, I guess. So I'm making this video because like I'm trying to figure out Am I just wasting my like? Is it what is the deal with this? Like, what is the deal with the whole distributing of heat? Does it really tend to just distribute everywhere, or do you tend to be able to separate it? Um, like in a universe somehow. And maybe you would have to ultimately use a black and white hole actually, because I mean, the whole basis of these equations is they try to treat there's like a change in entropy for like one specific, volumetric item, and then there's another one for like the surrounding system. But I need to sleep. Guys, let me know because I don't know. I feel like there is some sort of macroscopic. Macroscopically, forwards and backwards in time should be indistinguishable. When you look at this equation for heat transfer and they get like a negative because it's more mixed, that's a statistical argument. So macroscopically, is there some um, macroscopic way to do these things? To do these what maybe on the surface they seem to be statistically unlikely. Maybe on the surface it seems statistically unlikely to separate hot and cold globally. Um, Maybe it seems statistically unlikely to be able to separate like most particles on one half of the system and not on the other half or something like that, globally in the entire closed system. Because that's basically what law of thermodynamics is saying with this, with the actual thermodynamics part, with the heat measurement part, is it's saying that it has to be kind of leveling off, I think. But that's still a statistical argument, so it's not saying it's impossible for them to be separated, but that they just tend to not be. But that's still, that doesn't make sense with reversible physics. It just has to equal zero then, which, I mean, yeah, they have an inequality that says like less than or equal to zero. But that means we should be able to make all these little particle simulators, and we should actually be able to observe. That means we, like, basically what I'm saying, and I, like, all these little, like, simulations of, like, a hot cup of coffee or whatever cooling down, it's like you have to instantiate that cup of coffee into existence where it's at as the author of the simulation. And then regardless of whether you go forwards and backwards in time, you're just going to get a big mix, a big kind of, everything kind of evens out, and then everything's basically the same temperature. So that's just weird, right? That's something I'm missing something. I feel like I'm missing something with that. Because I feel like there has to be something macroscopic. Just like there's like this black hole white hole system, and people want to think of white holes as some little ball or something, but in reality it's got to be It's what's surrounding us, right? There's got to be some sort of analogy to that. There's got to be some sort of macroscopic explanation for there's got to be a macroscopic explanation for or sorry, I should say explanation for macroscopic things that we see all the time. But I just don't know how to I don't know if that actually like does that rely on the black holes? Because I used to think that I used to actually think that if you entered a black hole, you would pass through normally from your perspective, but what would happen to you is that you would turn into Hawking radiation from everyone else's perspective, and then the rest of the universe that you came from would essentially look like Hawking radiation themselves, or look like some sort of radiation to you, but you would now exist, as this radiation or whatever, as this thing that kind of switched over to being from a time-like to a space-like object. You would now be surrounded by, the other rays of radiation stuff. Um, and so basically with that, I was sort of thinking like, you know, you have like a redefinition of what uh not a redefinition, but like like a context change of like what time and space are, um, from certain perspectives. So you would have to basically realize that there's like you can look at the same universe, and depending on what dimension you pick as space or time, for example, or maybe some other things that you could measure, but just depending on how you define what you see, you see just like a file, right? You could have a file that looks like it's just a binary file, but instead of reading it from left to right, you skip every other bit, you know, and then you get a whole nother file. You get a whole different, it's still a file of the same size, but now the information is completely interpreted differently, but it's the same information because it's the same file. It's the same ones and zeros that you're reading from. And like I don't even know what I'm really trying to do here. Like I feel like there's some kind of there's something better that we can do than just stick to this, you know, just say like, oh, particles bouncing forward in time are, this look indistinguishable from particles bouncing backwards in time. Great. That's fine. You can state that, but that doesn't help explain necessarily how things are sort of um, like life. Okay, here's the thing that some people will get really wrong, right? They'll say something like, uh, they'll think that like the second law of thermodynamics is somehow like really analogous to like life, and that a creature gets old and then it just is old and then it dies because that's what happens to things like machines. The problem is that, like, first of all, one being tends to heal itself a lot and grow in its lifetime. But on top of that, you also have multiplication. So you can actually have like essentially what, some people would argue is the reverse of, disorder. Like it's actually becoming more ordered because you have a creature that goes and multiplies and creates more of it. Assuming that somehow the creature itself is considered ordered, more ordered than the rest of the environment. But like if you think about it, you could have both that happen. You could have creatures that consume more and grow and reproduce, and then you have creatures that could die off and go extinct. They're two different, like, kind of opposing things, but we're not talking about just bare bones physics anymore because, we have things like involved, like the sun providing energy. And obviously, for me to run my refrigerator, I'm consuming more energy. I'm never getting more energy out. I'm always consuming more energy to try to separate the hot from the cold. Uh, and when I say consuming, obviously the energy is not disappearing, into my, you know, electric bill or something like weird like that. No, it's that I'm having to cause the universe to basically, supposedly at least, right? This is just this is just a theory that I hear from like entropy, but basically I'm causing the universe to have to decide like to mix in more hot and cold together to try to separate. So the amount that I'm trying to separate the hot and cold from in my refrigerator from my house is less than the amount that I'm actually mixing hot and cold outside of that, right? Because that's like supposedly the cost. But my theory is that there's got to be something more than just that. Like there's got to be I either that's equal, either they're actually equal, but it's harder to measure depending on the like there either there's a more general way to measure this, and uh there's like another variable. So like it's not just regular entropy, it's like, some more advanced form of entropy, like some sort of advanced, some kind of somehow using, complex numbers or something to represent it, or something weird like that, right? Measuring something maybe that we don't know how to intuitively explain yet, but it's measurable somehow, or it's some quantity somehow. So either they actually there is something that is equal all the time, or their equations are right and it's actually, supposedly losing energy, but there's something to do with when you go through, there's something that like more fundamentally happens when you go through like a black hole or a white hole. The context is so the context, the local context around you is shifted so much. There might be a weight, basically. Man, this is so hard for me to try to like, because half of it's I'm trying to conceptualize, and then only part of it I'm trying to explain, and then like part of the effort is like going and explaining, but like a lot of it, it's just trying to conceptualize, like what am I even trying to do here? What am I trying to explain here? It's really like I'm confusing myself kind of a lot, but there's something my intuition tells me like you can't just have this like there's something that has to be missing if you just say, well, the entropy is just, it just increased in the global system, when the tea let its heat out. There's something about that seems like it's not balanced. Like something has to balance that out. And I don't know if that's something that would, takes like eons. But like there's there's either a flaw in the quantifying of entropy itself. Either there's a flaw in that, and that it actually needs to be more complex than just like this entropy number, or it's correct, but the global context is the thing that's actually wrong. And that when they say, well, the universe entropy is this, and when in reality you essentially can't reach all the universe around you. You can only affect it so much. So there's something going on with like these, with like essentially black holes, um, somehow moving enough, pushing enough context around. Thing is, I don't think about entropy enough to kind of understand how to try to intuitively, model it in my mind. I don't know what it really is as a concept. I mean, I think I know that it's something to do with, if you were to assume that you increased volume or something, there's more states. Um, Obviously, when you run a computer simulation, you can pick the starting state, but like when you run it and it just does stuff randomly, it tends to produce random results. So, um, that, that's what I'm trying to think about. And I never really thought about this before, but I got curious about it for some reason tonight. I've been thinking about some like physics stuff or whatever, and I'm at the point where I'm like, I don't get this. I like gotta figure it out. I gotta figure something about this out for some reason, just to make it make more sense. All right, I'll let you guys go.